Picture yourself standing in a dimly lit bar washed in purple light. Music hums in the background. Everything around you fades into shadow. You lift a clear glass of tonic water, and it suddenly glows in electric blue, as if someone plugged it into a hidden power source. It's not a reflection. There's no LED tucked beneath the glass. It's actually glowing, and here's what makes it even better. The substance responsible for that glow is the same compound once used to save people from malaria. We're talking about quinine, the very ingredient that made British soldiers grimace from its bitterness, now turning your drink into a miniature physics experiment in the middle of a party. It sounds like chemical magic, but there's no wizard here. Just optics. To understand what's happening, we need to meet a kind of light your eyes can't see. Ultraviolet light, or UV. Sunlight isn't just the warm yellow glow we notice. It contains shorter wavelengths with higher energy, including UV radiation. Human eyes can't detect it, but certain molecules can. Quinine is one of them. When UV light strikes a solution containing quinine, electrons inside the quinine molecules absorb that energy. Imagine an electron as someone sitting in the lower row of a theater. When it receives enough energy, it jumps to a higher seat, but that higher seat is unstable. Within a few billionths of a second, faster than a blink, the electron drops back down to its original position, and when it falls, it releases the extra energy as visible blue light. This phenomenon is called fluorescence. In simple terms, quinine swallows invisible light and spits out light you can see. No batteries, no combustion, just energy conversion. That blue glow isn't food coloring. It's the optical signature of the molecule itself. The story becomes even more interesting when you zoom out historically. The 19th century was an era when scientists were becoming deeply curious about light and energy. When chemists discovered that certain substances could glow under UV light, they didn't see a party trick. They saw clues. Fluorescence opened doors to understanding molecular structure. It helped reveal that matter isn't just solid and silent, it's made of particles that absorb and emit energy in predictable ways. From early experiments with solutions like quinine, science eventually advanced toward fluorescent lamps, fluorescence microscopy, and later, techniques that label cells with glowing markers in biology. If you've ever seen an image of cells glowing green or blue under a microscope in a laboratory, you're witnessing the scientific descendant of the same effect happening inside a glass of tonic water. It's a little surreal to think that a drink at a bar has distant ties to cancer cell research. Isn't it? But science often begins with ordinary observations. There's another small detail most people overlook. The brightness of tonic water's glow depends on how much quinine it contains. Diet versions or premium brands with slightly different concentrations can glow with subtle differences in intensity. Place 2 glasses side by side under UV light, and you might notice one shining more vividly than the other. In other words, you're holding a rough concentration indicator in your hand, visible to the naked eye. In laboratories, scientists use spectrometers to measure fluorescence intensity and determine chemical concentrations. In a bar, all you need is a blacklight and a bit of curiosity. That glowing moment isn't just beautiful. It's a live demonstration that energy never disappears. It simply changes form. Invisible UV radiation transforms into visible blue light. High school physics. Served with ice and a slice of lime. So, next time you see tonic water glowing under ultraviolet light, don't treat it as just an Instagram effect. You're watching electrons leap between energy states. You're seeing the interaction between electromagnetic radiation and molecular structure. You're witnessing a small chapter of scientific history packaged in a clear, sparkling drink. Perhaps the most beautiful part isn't the blue color itself. It's the realization that the universe's quiet wonders aren't hidden in distant galaxies. They're tucked inside the everyday objects you hold. A glass of water, a natural compound extracted from tree bark, a reaction unfolding in billionths of a second, an entire world of physics concealed beneath carbonation. If you enjoy that feeling when something familiar suddenly reveals a secret, then believe this: there are countless other experiments all around. What's waiting for someone to switch on the UV light? For now, If you ever find yourself in a bar bathed in violet light, raise your glass of tonic just a little higher. Not only for the photo, but to remember that you've just watched a molecule absorb energy and tell its story in light,